Now we have seen the excess pressure across a spherical surface, across any arbitrary shaped surface, across a cylindrical surface also. Now one more point to consider, we have a soap bubble and the excess pressure across this soap bubble we have already seen, it comes out to be P1 minus P2 equal to 4S by R. Say here I want to write R1 because I am going to do something which will change the radius of the bubble. Now if we give charge to this bubble, if we give some charge to this bubble, so this I will call charged bubble, charged soap bubble. Then what happens, you see, say here this is P1, this is P2. So here if I mark P1, P2, (4S by R) pressure. So P1 equal to P2 plus 4S by R. Now here what will happen? P1, P2, 4S by R, and another one sigma square upon 2 epsilon naught. Sigma is the surface charge density. About this you will understand it later. And sigma square upon 2 epsilon naught, this is known as the electric pressure. About this we will study in the electrostatics. It is electric pressure. So here because of this radius changes, say it is R2. So instead of 4S by R, I want to write it here R2. Now here the pressure will come P1 plus sigma square upon 2 epsilon naught equal to P2 plus 4S by R2, or you can say excess pressure is equal to 4S upon R2 minus sigma square upon 2 epsilon naught. That is, I'll marking here P1 dash P2 dash. P2 dash and P2 will be same because same surrounding. P1 dash will become less than this value, right? So this is the excess pressure here. If we want to find the value of R2 also, then sometimes question can be framed like this, that assume under the temperature of the air enclosed by the bubble remains constant, that is the Boyle's law is there, then what is the new radius? In that case you can do P1 V1 equal to P1 dash V2. P1 is given as 4S by R1 plus P2 into 4 by 3 pi R1 cube equal to P1 dash is equal to P2 dash. P2 dash is same as this surrounding, so I can write P2 only. P2 plus 4S by R2 minus sigma square upon 2 epsilon naught into new volume 4 by 3 pi R2 cube. By using this equation we can find the value of R2 also, new radius also, right? This is when a soap bubble has been given the charge, then what happens, that has been explained, right? Next point you take, when you blow the soap bubble, like most of you might have done this type of thing, a toy comes where some rod type thing is there, you blow the air and soap bubble will form. You have blown the soap bubbles and they are simply floating in air. Then sometimes you touch the one soap bubble with the other one like this way, and when you add them, when you simply touch them, then this won't be the shape. The shape changes something like this. So we are interested in finding the radius of the common surface, right? We are interested in finding the radius of curvature of the common surface. Once again I am telling you what we are going to do in this part. This is, we call it as the radius of the common surface of double bubble. Right? So what is there? We have two soap bubbles of radii r and small r. Then here the pressure P1, surrounding pressure is P2, P0, P2, P0. So for this we will write P1 minus P0 equal to 4s by r, and for this we will write P2 minus P0 equal to 4s by r. When we join them, when these two will come in contact, then the radius of this common surface is neither equal to capital R nor equal to small r. It will become like now, because of this process, we are going to assume that there is no change in the pressure, because pressure will almost remain same as original values. So here pressure P1, pressure P2, and this radii of curvature is becoming, say, R0. R0 it becomes. Right? Then, how to write the pressure difference? Here it will come, concave side I am assuming this side, convex side this side. So pressure on the concave side is more than the convex side by 4s by r0. This is also going to be spherical in shape, but its spherical radius will be like this way, right? So P1 minus P2 equal to 4s by r0. And if we find from here P1 minus P2 is equal to 4s by r minus 4s by r, or I can write P2 minus P1, because it is a negative, it is bigger number, P2 minus P1 is equal to 4s 1 upon r minus 1 upon r. This will come, right? This is positive. Here actually this will be smaller, this will be bigger. Let's make it correct only, otherwise you will be getting confused. The convex surface is not on this side, rather means radius of curvature center will be on this side. This is R0. Then we have to write P2 minus P1 equal to 4s by R0. Comparing these two, we will have 4s by r0, and we can say 1 upon r0 equal to 1 upon r minus 1 upon r. This is the radius of curvature of the common surface of the, when the two soap bubble has been joined, right? Let's discuss one more aspect. This is all about the excess pressure across a curved surface. Now in the next video we are going to see the splitting of the drops.